Hey guys, welcome back to another episode of Tech Guys Radio. Today, Gemini and I had interesting conversation about parallel programming considerations in the C programming language. So if you guys are interested in parallel programming, C programming language, you're going to love today's episode. We're going to go over a bunch of cool topics related to parallel programming, specifically with the C language. So if that's of interest to you, stick around for today's episode. If not, feel free to skip today's episode, check out one of the other ones, and let's get started. So when you want to utilize multiple CPU cores in your C code, you're essentially dealing with parallel programming. Here's a breakdown of the common approaches with a focus on how to achieve this. And shout out to Gemini for this brilliant sort of summary she gave. Right, so threads, specifically pthreads, POSIX threads. Right, this is the most common way to create and manage threads in C, especially on Unix-like systems like Linux, macOS. You create threads, each of which can execute a separate function. This allows you to distribute tasks across multiple cores. Okay, we're going to go over some key functions. So pthread underscore create function creates a new thread. Exactly what it sounds like. Pthread underscore join waits for a thread to finish, while pthread underscore exit terminates the thread. So those are three key functions that you're going to have to memorize. And we're going to do an example of some conceptual code in C. So we're going to start with hashtag include pthread.h, hashtag include standard.io.h, void star my underscore thread underscore function void star arg, and then the code to be executed by the thread. So we're going to printf thread execution backslash n pthread underscore exit null. We close the myThread function. We write the main function int main pthread underscore t my underscore thread pthread underscore create. As a parameter, we pass in and my underscore thread comma null comma my underscore thread underscore function comma null pthread underscore join. As a parameter, we pass in my underscore thread comma null printf function. As a parameter, we print my thread finished backslash n return 0. There's our main function. Alright guys, so pthread. Okay, we're going to use pthread functions, and remember pthread just stands for POSIX threads. Alright, so it's the most common way to create and manage threads in C. Alright, so that was so confusing for me for a while, but it was clearly explained. I walked through it, tried the code out, and now I'm sort of getting a grasp on it. Alright guys, so definitely review that code I just mentioned, and then once you're good with that, you can move on to C11 threads. So this is interesting. The C11 standard introduced its own threading library, threads.h. It provides similar functionality to pthreads, but is part of the C standard. However, its adoption has been somewhat inconsistent across compilers. So C11 threads, something else to keep in mind in addition to pthreads. So you want to kind of know both, okay? Because once you understand both pthreads and C11 threads, you'll be well on your way to parallel programming in C. The second thing to consider is sort of the operating system scheduling. Your CPU affinity. Operating systems schedule threads to run on available CPU cores, and you can influence the scheduling by setting CPU affinity, which restricts the thread to run on specific cores. This can be useful for performance optimization in certain scenarios. On Linux, you can use the schedule_setAffinity function system call. Right guys, that's CPU affinity, because we're going to have to use some operating system scheduling. Okay. Then we move on to OpenMP, Open Multiprocessing. Directive-based parallelism OpenMP is a higher level approach that uses compiler directives to parallelize code. It's particularly useful for parallelizing loops and other structured code. The compiler and runtime system handles the details of thread creation and management. This simplifies parallel programming compared to working directly with threads. And then she goes on to give some example conceptual code in C, hashtag include standard.io.h, hashtag include omp.h, int main function, hashtag pragma, omp parallel, open curly braces, printf, hello from thread, modulus d \n, comma, omp underscore get underscore thread underscore num function. All right, so we're gonna print that, close curly braces, return 0, close curly braces for the main function, and that's sort of how we use OpenMP. All right, guys, hashtag include omp.h. Okay, and then we can use OpenMP directive-based parallelism. Are you confused yet? Good. All right, so some important considerations to make. Synchronization. When multiple threads access shared data, you need to use synchronization mechanisms like mutexes, semaphores, etc. to prevent race conditions. Overhead. Creating and managing threads introduces overhead. Parallelizing small tasks might actually slow down your program. And last but not least, data partitioning. To effectively utilize multiple cores, you need to partition your data and tasks so that they can be processed independently. Remember to consider all three: synchronization, overhead, and data partitioning. Once you sort of have a grasp on that, you'll be well on your way to parallel programming in C. In summary, for fine-grained control, use pthreads. For simpler parallelization of structured code, use OpenMP. Use CPU affinity when you need to control which cores your threads run on. Alright guys, as always, make sure to subscribe to Tech Guys TV. If you like this episode, drop a like. If you have any questions, leave a comment, and I'll see you next time.